models and what tools are available. And I'll show you some demos on what actually can be done from all the information that is available in the models themselves. So most of you are familiar with model-driven development, which was all the craze about 15, 20 years ago. And I think this is now a second, if not third generation of this approach. But we all know that the model-driven development doesn't work if the models are not done right. So we trust the clinicians to do the models right, and hopefully Ian has convinced you that it's not easy, but that there has been significant progress made over the last years in building good models. So we talked about this in the morning, and hopefully by now you've seen some examples on how this is done. But as we said before, all this is built on common data models. But also, if we want to realize on this vision, we need high-level tools that enable people to build these applications quicker than the usual way of building applications of today, which takes a very long time, is costly, and of course, builds monolithic systems. So how do we actually, and I've gone through this in the morning. So what's available? What can you actually take the models, put them in a system, and actually build applications from? So a health data platform is a cornerstone of this delivery process. So the applications, as we said in the morning, rely on a data platform to serve the data. And by applications, I mean applications from a single vendor or from many other vendors as well, or multi-vendor environment. But basically, what the features are that it's a repository, it's a receiver for the integration of existing data from legacy systems. It's designed as an API layer, which means that the APIs are offered to others to build on top of these on this data. And hopefully, we are getting much better at providing tools which enable developers, and maybe not even just the developers. We're talking about end users that can build some applications. Now, there's several components to a platform. This is our example, where there is a server. There is something we call an explorer, which actually lets you look at the data. Again, this is bypassing the applications themselves. Usually an application would be doing this. Some components that enable the integration, or at least make it easier. Development toolkits for software developers in web, iOS, Android, and so on. And the modeling piece, which was already discussed in the previous example. So the vision here is, since we are spending a lot of time and effort building the models, why don't we reuse these definitions, these specifications of data when we are building applications, things like forms? Why don't we reuse the tie-ins to terminology, the translations, the validations, without having to repeat and code this again? This would allow us to build an app, build a form, embed this form into a portal, like the Salus portal that was mentioned earlier by Plymouth, and then do analytics on this data and really make sure that this loop can go quickly. So we talked about the modeling. I'm going to skip this. We have a tool called the Form Builder, which actually uses a drag-and-drop method of building a form based on a certain template. Now, the form that is built is ready to be used in web and iOS. You cannot build the most complex application this way. So something that I'll show later, which is the e-prescribing, is a very complex application. But it turns out that an application like that has a lot of other requirements that can be built using simple forms. It can be entered as data using simple forms. And it would augment the original product. But the main thing is it can be built really quickly, in a lot of cases, even by the customer himself. frameworks that allow us to build the natively built applications that I was talking about before. So things that make the developer more productive. Again, he's relying on somebody else doing the modeling and code generation to build stubs of applications, especially where it ties into the data. And it's much better to see this than to talk about it. So the idea of this approach is to use as little code as possible and to use visual tools to provide this functionality. But of course, a lot of it is provided by the approach itself, like the example in the end, because we're entering into the same data store, all the applications connected to this data store come alive as soon as you enter data. So this is one approach. After we have built the application, we have entered all this data, we need a tool to analyze this data and to query it. And this is where the Explorer comes in, where it makes it a little bit easier to get at this data, to display it, to see how the queries work, to export it, and so on. So integration, of course, whenever you come into healthcare, you realize that you are never in an environment with no legacy. So there was a joke the other day that God created the world in 7 days, but he had no legacy. So unfortunately, we do. And the slides from Andy were quite troubling, right? The big architecture that's in place. But what we're trying to do is to get alignment with tools that provide this integration, because of course the vast majority of data is not in the right format yet. We hope we will not be adding to this problem by putting the new data in the openEHR format. But the reality today is there's a lot of data out there, and we need to normalize it, store it properly. And for this, we use different types of integration engines. But our job is basically to make it easier to do this integration by providing some tools in this regard. We mentioned the way to distribute the archetypes and the knowledge through the CKM, and this was in the previous one. Airscape is a portal where you can actually learn how to build these applications. But the bottom line is we're trying to make it as easy as possible to get on board, because honestly, it's not all that easy. I mean, it does take a learning curve. It's something new. It's not just the modeling that is hard, but actually thinking differently, thinking that I mentioned before, for IT people to have clinicians do the model, it takes a little bit of, well, sometimes even pressure, because they don't think like that. They just build the model. How can clinicians build a better model than IT? And I'm an IT person. I understand their frustration. But I think we've proven that actually it is true, and that's how it should be done. So if we look at the applications today, most of them are built like this. So all types of code mixed up together, inseparable. And it's quite clear that we would really like this approach on the right, because this lets us reuse certain layers of code. And we actually immediately recognize that this is where openEHR plays in the data space, and the ability to reuse the layers above, even if it's just one layer, even if it's just an iOS app and a web app speaking to the other three layers, this is something that the new architectures have to be able to do. And of course, I'll try to show you how we can do this with an existing app, which is, well, hand-coded is not the right word anymore, basically done traditionally, and then extended through the use of the forms which are built exclusively with tools. ThinkWord app is again, programmed in iOS, but it has the capability to go to the server and ask for which forms are available for me, and those forms are built using the tools. So with that, I'll hand it over to Anže, who will tell you about openEP, which is quite a complex application, but entirely built on top of the platform. So Anže. This, or you want to just use that one? You don't. You want this one. Okay.
There's adverse drug reactions that could be prevented, cause or directly or relate to almost 6,000 deaths each year in UK alone. That's a lot. That's 15 deaths a day that could be prevented. And there's another aspect to this, not as important, but still. This costs money. And there's an estimate that this costs £640 million, again, in UK alone. These are hospital ADRs that could be prevented. So I strongly believe that healthcare IT can play a crucial role in preventing such events, can help save lives, can optimize the outcomes of patient care. But again, it needs to be done in a smart way. Why? Because if you just introduce a healthcare solution into a hospital, which is already a very complex environment, what can happen is this. Can you see a doctor and a nurse? Well, one is looking at the iPad, very new, shiny iPad, very good. The other one is looking at a bedside PC. Again, very well, high-tech. It's near my bedside. But hey, who's working with a patient, right? There's a patient. Did anyone even notice the patient? So that's not good. We should be developing healthcare IT that actually has the best interest of patients in mind. It should be patient-centered, right? And imagine if we could have a healthcare like we had maybe 100 years ago, but where the patient is in the middle, where all the focus of all the medical teams is really on the patient, but with all the knowledge that we have today, and with all the technology and all the healthcare IT and all the health apps and smartphones and tablets working for us in a way that they are transparent, so they don't obscure the process of caring for the patient, but they are somewhere there helping everyone achieve better outcomes for patients. And with this idea in mind, it was 5 years ago when me and my team and a group of clinicians, clinical pharmacists, and nurses started developing a medication management solution, right? We wanted to develop a healthcare IT in a way that it's going to be different, so that it will not further complicate the life of medical teams in hospitals, but it will actually help them. It was quite a challenging task. And if on day one we would start working with technology, trying to figure out all the standards and the data models and whatnot to support all of that, we would spend a lot of our crucial time designing architectures instead of focusing on usability, on safety aspects, and so on. So this is where openEHR was really handy, because we had medication management models done. We could use them, so we didn't have to use time to actually argue how to store the data, but we could start, luckily, with no legacy, like Tomaz mentioned, and go directly to just brainstorm the scenarios that doctors needed, right? And nurses and clinical pharmacists to improve the overall care for the patients in terms of medication management. So what we did in a couple of years, through trying and failing and prototyping and iteratively developing the system, we developed what we call a comprehensive medication management system, or nowadays I can happily say it's a closed-loop medication management system that supports all possible medication management or prescribing scenarios that you can think of. If you can think of another one that's not supported, we'd be happily adding it to the stack. Why? Because it has no sense of having a medication management system that cannot cover everything you can already do on a paper. Because if there's a single scenario that you still have to do on a paper, it's even more dangerous than only in a paper world. So think about that. So once we did that, we were really proud. I was very happy. So we cracked this. We have now 22 different scenarios of prescribing. We even support infusions, medical gases. We support protocols. We support pediatric prescribing. All very nice. But when I show this to doctors, they say, okay, but well, I can do this on paper. So why would I use this system? I said, yeah, you're right, but you can structure it. And they go, really? That's how you're going to sell it to me? We don't care about structuring the data. So these are all the baselines, right? But it took us like 2-3 years to figure them. They're important, I'm not saying that, but there's no added value for clinicians, not directly. I mean, you can save, you can prevent errors around transcribing, legibility, and all of that, but that's not really the value of such a system. The value comes when you actually start doing smart things, when you tap into the resources that you have available. Like if you can pull out the lab results or your observations on one side and join these on one screen with your, let's say, insulins and blood sugar. One screen. So you have a trend of your insulin. You have a trend of your blood sugar. And these are all different processes, right? So blood sugar is measured by nurses during the day, during the inpatient stay. But now having the power to have this on a single screen at the time of prescribing, well, that adds value to doctors, right, when they're prescribing. Because on paper, they cannot do that. Another scenario, antimicrobial stewardship, right? Everyone knows this is a big problem. Everyone knows this is an area where there's a lot of mistakes, where there's a lot of potential to improve. But again, on paper, it's really, really hard. Having an IT system in place that can help you with that, well, that's an added value for all the care teams. Because you can create automatic reminders that after 2 days suggest to switch from IV antibiotic prescriptions to oral, if possible. You can set reminders. You can set hard stop days. These are all the things that on paper can be forgotten or are difficult to achieve. There's medication administration. Let's face it, this is a really, really crucial activity in medication management. And no one respects nurses when they're administering medications. Everyone thinks they can just ask that one question at the time when she's giving the injection. And then she goes, did I already put the injection? Let's give it anyway. So you shouldn't be bothering nurses when they're administering, right? It's dangerous. And, you know, IT, again, can help a lot. We can give them task lists that help them plan their day, when to give medications to whom. We can give them barcode scanners to close the loop, to scan the medications, to make sure they have the right pack for the right patient and not make the mistakes there, right? Then we can give doctors order sets. I mean, the biggest request I get from the doctors is, will the system give me a dose recommendation? Not yet. It's really difficult. And if you're clinicians, you probably know why, because you have like allowed dose for methotrexate, which is in the books more than 1,000 grams, but only if you're a cancer patient. If you're not a cancer patient, 1,000 grams will kill you. So how do I build this in? If someone didn't put in the condition, the system will say, okay, 1,000 grams is fine, but no, it will kill you, right? So getting the decision support right is really a challenging bit. Order sets can go a long way, because you can have good suggestions. So you don't have to always check your little books, what's the right dose for that? But it's here, right? The other thing that can help and go a long way is decision support. Again, unfortunately, today, the decision support is not on a level that doctors would want, where, you know, they would recommend everything, warn you about everything, give you the exactly right, you know, dose or order sentence. But they can warn you about allergies. They can warn you if the medication is maybe not really the best for the condition you're prescribing. They can warn you on indications or contraindications, interactions with medications. So again, it can prevent a lot of potential errors. And these are all the things that you cannot do on paper. So this is adding value when you're introducing healthcare IT to your users. And of course, with medication management, closing the loop is also very important. It can save a lot of time. It can prevent a lot of errors. And one of the things that we found out at the Children's Hospital is that we were actually able to save 6 hours a day when we implemented the ability to print out the labels for syringes and the ability for the nurses to actually scan those syringes at the bedside. Why? Because before that, they had to manually write the label for each syringe at the ICU, and they had about 200 syringes to prepare on a daily basis, and that just took 4 to 6 hours each day. You have to be careful about what you're doing. You can imagine a lot of mistakes can happen when you're transcribing from another piece of paper, and again, someone just comes along and, hey, just tell me, how's the weather outside? Again, you don't want that. And think further, right? The moment you go from hospital, patients have to adhere to medications. Otherwise, the treatment is not as effective. You know, your state is not getting as better as it should, and there's nothing at the moment that could help you do that, right? Okay, you can have a reminder set up, but will you really, as a patient, you know, set your own reminders for medications? You will not. So you need some sort of a way to seamlessly transfer your discharge prescriptions to your app. But the moment you're doing this with different apps, with different vendors that don't really understand each other, you're limited. But if you have a clinical data repository that everyone understands, that the models are, you know, open, understandable, you can stimulate this kind of apps that start talking to one another. openEP is one such comprehensive system that's built on top of the ThinkEHR platform, and it's to a full extent leveraging the capabilities and possibilities that are possible, that come with having a vendor-neutral clinical data repository. We are pulling the data in from labs. We're pulling the data in from EOP systems. We are pulling the data in about conditions and so on. And it doesn't matter where this data comes from because it's stored in a vendor-neutral format. And openEP is only always querying that one single point. So if the data is there, fine, we can do something smart about it. If not, well, that piece of functionality is missing. But can you understand what that means? That means that when I come to a hospital with an openEP, I don't have to worry about integration, right? I just need to query this one single data repository. The integration happens or it doesn't. It's a different process, a different project. Also, if I want to enter allergies or conditions or observations, do you know how challenging it is to set up even one of those processes, like getting doctors to code diagnosis at the time of admission and not like 2 days after the patient is discharged, or getting all the lab data insight in real time and observations? So if you are doing a healthcare IT project, you shouldn't be spending time on things that are not part of that particular project because you're never going to get through. And once you have a piece that's really well, supported, one of those processes, and it's generating good clinical data, why wouldn't you just take advantage of that, store it in a single place where everyone else can use it, right? So this is a different approach that all of a sudden is possible. And this is an example of what we're doing in Plymouth, right? We're doing exactly that. So they're building their own PAS system. It's a really nice system. It's used on all the different wards. It would be a crime to, force them to use something else. So we need to take advantage of what they've already achieved, but just add one additional building block, which in this case is medication management, into it. And it will tap into the clinical data repository that they have. It will get the data from other parts, and it will work nicely in the whole ecosystem. And then someone will come along and say, listen, all this healthcare IT is great, but really logging into all these old-fashioned computers and PCs, I want my smartphone, which I have in my pocket. I want my tablet. I want to use it there. And then your vendor will say, OK, but we don't have an iOS division. We'll have it ready in 2020, maybe. Is that OK? And you're going to say, no, I want it today. So fine. Find a local vendor in your local, business environment that wants to do that app, but has no idea about HO7s and fire and water, and all of that, and openEHR. What's all that? They don't need to know that. It doesn't matter because now the trust has an infrastructure with APIs where they can hook up with a local developer who has really good, front-end skills, will get you a really nice app, but get all the data from the clinical data repository and just present you that on the smartphone. It can be done very quickly with much less money. And the trust can re-innovate or reinvent how they're doing procurement, right? They don't have to go through all those long procurements requesting that vendors know all about healthcare, have multi-million or government level references because it's no longer important. So it's changing how healthcare IT can be done. And it's much, much more agile. Well, that's a brief thought on medication management and how an ecosystem can be used to augment that. Thank you.
Okay. One more slide. So to finish, I just want to show you something that we're working on, which is how to connect the devices to the applications themselves without using Okay, just to show you something we're working on in the lab, which is these new devices that are coming along, Bluetooth 4 or Bluetooth Smart, actually have the ability to speak to the device, the machine, the computer directly without going through a gateway. And this affords some really, really interesting use cases that we'll see here.
So there's lots to do and lots of opportunity. And I think all these technologies that are coming are making it much easier to build these applications, and above all, much faster. So we've seen today how openEHR solves the data problem. Of course, we'd really like to go to the next level, which is how do we deal with process and business rules?